Hello everyone, this is a tutorial for the Educational Codeforces round 125, weighted for Division 2. I will be solving problem A and B. So the first problem, integer moves. There is a chip in the point 0, 0 of the coordinate plane. In one operation, you can move the chip from some point x1, y1 to some point x2, y2 if the Euclidean distance is an integer. That is, if the result of this formula is an integer. Our task is to determine the minimum number of operations required to move the chip from the point center to the point xy. So xy will be given, and we have to calculate the minimum number of operations required to move from center to this given coordinate. So we gotta draw. So we are at starting position is at the center, and let's say some coordinate is given xy. So we have to move from center to this position, and we have to calculate how many steps taken to go to this position. Okay, so let's try an example. 8, 6. So even our position is 8 and 6. So let's say it's somewhere right here. So first things first, can we directly go from center to the destination? For that, let's calculate the Euclidean distance. So here, x1 minus x2 whole square plus y2 minus y1. So this is basically equals to 8 square plus 6 square, right? And this should be 100, so the square root would be 10. So this is an integer. We can directly go from here to here with one step. Let's try another example. Xy given center. So if it is at center, we don't need to go from anywhere. So we are already at the destination. So number of steps required will be 0. So let's try another one. 9, 15. 9, 15. Okay. So if we calculate the Euclidean distance from to 9, 15 from the center plus 15 square, the solution, whatever the solution, will not be an integer, will be a decimal point, a decimal something. So what can we do here? You see, we can apply a logic. Instead of going to 915, we can move to 9, 0, because and this will be possible because 9 square, root over of 9 square would be 9. You see, from 9 from 0, 0 to 9, 0, the Euclidean distance will be 9 square plus 0 square. This will be 9. And from here, we can move to 9, 15. This will also be possible because here the Euclidean distance will be 9 minus 9 square plus 15 minus 0 whole square. So this will be just 15 square, that is 15. This part will be 0. this part will be 0. So number of steps is 2. So let's try another example. Let's say 7 and 17. Okay. So from 0 to 717, can we go directly to 717? 7 sorry, 7 square plus 17 square equals to, let me calculate, 338. 338, and this is not a, the result will not be an integer. It should be, it will be 13 root 2. Okay, so this is not an integer, so you cannot take the direct approach. So let's say we go to 7 nil 70 first, and this is possible because we know the Euclidean distance will be 7 square plus 0 square. This will be simply 7. From 7 0 we can go to 7 17, and the Euclidean distance will be 0 square plus 17 square is 17. So this is okay, this is okay. So the logic will be, if we can directly go from center to the destination directly, then number of operation will be 1. If we cannot go directly, and if it is not at center, then the operation will be 2. So let's check the code. So I'm using Python, and as you know, when we have number of tests is a lot, let's say 10 to the power 3, 4 or 5 or even bigger, then Python will be very slow and will hit TLE. So I'm using a fast IO to tackle this. I've taken T here, and then my main code is here. So at first, after taking the input, I'm checking if my coordinates are 0, as in center. If I'm at the center, then I do not need to carry any operation, so I'll just print 0. And then and if it is not at the center, then I will calculate the Euclidean distance here, and I'm also calculating the square and square root, and I'm checking if the square root is 0. That is, if the square root is an integer, I'm printing 1. If it is not an integer, that means I cannot go directly, then I will just print 2. Second problem states that we are given 4 integers n, b, x, and y. We have to build a sequence from a0 to an where the first sequence is 0, and for the rest we can have 2 possible situation. One where the ai is equals to ai minus 1 plus x, or ai equals to ai minus 1 minus y. In other words, the element will be either a previous element plus x or previous element minus y. Okay, and then our goal is to build such a sequence that ai is less than or equals to b, and the summation is maximum possible. Okay, then we are given, okay, t is 10 to the power 4, and then we are given 4 numbers n, b, x, and y. So there will be n elements in our array, and then each element has to be either less than or equals to b, and how to select that element will be up to us. So it can be either this or it can be this. So let's try to understand the problem more with examples. So let's say we are given 500, 130. So n 5 p x I 500 130. So we'll have 5 elements. Okay, so let's start. The first element is 0. A0 should be 0, and for the next element we can choose either 0 minus sorry yeah. It can be either 0 plus x or 0 minus y. So if we select 0 minus y, it will be minus 30. If we select 0 plus x, it will be 1, and both of them are less than or equals to 100. So we will take the maximum possible, that is 1, because our target is that the sum should be maximum. Okay, now for the next element, 1 minus 30 is a negative number, whereas 1 plus 1 is a positive number. So clearly we will take 1 plus 1. So 1 plus x, that is 2. Again, 2 minus 30 is a negative number. 2 plus 1 is positive. So this is clearly a higher value. We'll take 3 and so on, 4. So we'll go up to like 5 elements. 5, sorry, wait. 5, apologies, there should be one more. So 5. Because like every time we're adding 1, so 1 to the previous element. So and now we will calculate the summation. So 3, 6, 10, 15, and this is the maximum possible sum. Let's see another example. 4, 1, 7, 3. Okay. Okay. Given 4, 1, 7, 3. So let's start. First we have 0. We can, so 0 plus 7 is 7. 0 minus 3 is minus 3. So 7 is higher. So we'll take 7. Oh, now the problem is 7 is higher, yes, but 7 is also greater than 1. And our condition was AI must be less than or equals to B. It cannot exceed B. So we have to take the we have to take 0 minus 3 here. Minus 3. Again, minus 3 is minus 6. Minus 3 plus 7 is 4. But 4 is higher than 1, so this is not possible. We have to take minus 6. Minus 6 plus 7, 1. Minus 6 minus 3 is minus 9. Okay. Both satisfy the condition, so we can take 1 here. We don't need to take this. So 1. Okay, 1, 2, 3. One more element left. So 1 minus 1 plus 7 is 8. 1 minus 3 minus 2. 8 is greater than 1, so we cannot take 8. We will take minus 2 here. Our array is complete, and the summation will be the maximum possible. So here the logic is quite straightforward. We will calculate both x and y. We'll calculate both x and y, that is AI equals to AI minus 1 plus x. So let's say n1 Also this, and we'll also calculate another element, another number, ai minus 1 minus y. So we'll calculate both the numbers, and then we'll check if which number is greater and satisfies this condition, and then we'll just add to our let's say a variable. We'll calculate we will have a variable total, let's say, and then we'll just add it to it. So let's check the code. So at first I'm taking all the inputs, and then this total is the variable of for summation of the array, and then I'm traversing the array. Here a is the previous element, and n1 n2 I'm calculating both the possibilities of operation. So a plus x, that is previous element plus x and previous element minus y. And then just a second. So and then I'm checking if the n1 is greater than n2 and n1 is less than or equals to b. So if both these conditions are satisfied, that means n1 is our suitable number, is our desired number. So we'll add that to our total, our summation, and then make a and replace and update the a, that is the previous integer. If n1 does not satisfy this condition, that means our desired element is n2. So we will add n2 in our summation and update our previous element as n2. And finally, we will print the summation. And so that is all. Hope you understood the problems and the approach to solution. Thank you very much for watching.